It's been a while since I've made any videos, about 6 months or so. So this is the longest period I have had away from my YouTube channel. Now I've got about 1200 videos here on the channel, and it would be a shame just to let it all go. So what I intend to do is to pick it up again just slowly, maybe put in a video or two out per week, and focusing just on the kind of things that I am interested in at the moment. Now, there may be people out there who have watched the channel before and they're interested in finding out about the Design a CPU 4 course. Well, everything is ready for the course, but I just haven't really had any time to put it together. I work at Glasgow University International College, and I have been lecturing in mathematics and also in statistics. So this has taken up an awful lot of my time. Now, another thing to note here is that if my image disappears in the next few minutes, okay, then I'll just keep talking without it. Oh, there's something strange going on with my camera, but who knows, it might last for the next half an hour. So what you see in front of you here is the circuit for the finalized circuit for the Design a CPU 4 course. Now I'll talk through it just quickly, just to give you an indication of what we've got for the course. My initial idea was to add in a Cordic unit, but the Cordic unit was going to be so large and take up so much of Logisim's time that it just wasn't feasible to integrate it into the rest of this CPU. So I will create something separate that we can run as opposed to running it within the CPU here. So you can see here that I'm generating a cosine function. So we're in the happy position here where we are able to generate some basic mathematical functions. Now this mathematical function is being generated in a floating point unit. So if I was to just drop in here, then my initial thought was to put the floating point unit here as a separate card. So in effect we would think about the floating point unit as being a separate chip from the CPU. So it would be kind of like the old back to the 1980s, where we had say a math coprocessor, which would be a separate chip from the CPU. But it wasn't very quick doing it like that, and it's much better for us if we actually just incorporate the floating point unit into the CPU, which is what it would be like in terms of a modern processor. So if we get in here, you can see it's a little bit small. Make it a bit bigger. You can see we've got the floating point unit, and this is the floating point unit here. Now the thing about the floating point unit is that the circuitry within the floating point unit is probably potentially twice the size of the circuitry for the entire CPU. So it's quite a complex bit of equipment. So I'll just quickly drop in so you can have a little look. Now a thing to notice here as well, that you'll see some of the lines are actually red, which means an error, okay? But it's not an actual error, it's like that on purpose, and whenever I do the course I'll go through and I'll explain why that is. So I've got a multiplier, an adder, subtractor, a divider, a square root, and we've also got a float to integer converter. Okay, so this is the basics of the guts of what's going to be in the Design a CPU 4 course. So we're going to go over some of this and how some of this works. Okay, I can't cover all of it in the course because I already have separate courses for 32-bit, a 32-bit floating point unit. Okay, so that goes into this in minute detail. So in the Design a CPU 4 course, I'll go over a bit of a summary of how the floating point unit works. Now, another thing to note here is that we've got Visual Studio Code Editor, and the program that you see running now is this program here, which is generating the cosine function. Okay, so from this Design a CPU 3 to Design a CPU 4 course, the assembler has changed a little bit, and we've got some different commands, and we've got different ways of writing the code. But we'll go over the new code within the Design a CPU 4 course. So I'll just quickly let you have a little look here. We set out the position where the code is going to be ran. Okay, so this is where the actual code is held, 0 cross 8000. We've got these equalities here, so we can, for example, let this float underscore cosine is equal to this memory address. So I think you can see my image has just now disappeared. Okay, so it doesn't matter, not make any difference. I'll just keep talking on anyway. Take that off. So the rest of the code here just works through and generates a loop which puts in 100 different values for radians, and then it works out the cosine of those values and then plots it off onto the screen. Okay, so there's some nice stuff in the new assembler, and it will be good to explain that and for you to see exactly what's happening with it. Now, there are quite a few mathematical functions. So we've got sine and cosine and the tangent function. I've also generated an exponent and also an e to the x. And from the e to the x, I've generated the hyperbolic functions as well, so the sines and cosines. But there's lots more that we can do with this. We could, for example, generate the inverse functions. But remember, Design a CPU 4 course isn't a course about numerical methods, okay? It would be nice to go on after this and generate an actual course on how to write a proper library, and we could use this little CPU here as a test bench for it. So that would be a nice thing to do. But the library we've got here is relatively large, and it's large enough for us to do lots of interesting things with this CPU. So for example, you'll see in the course we generate the Mandelbrot set. Okay, so we are able to plot out a basic function, basic display of the archetypal Mandelbrot set. Now, if you've not heard of that and you don't know what that is, then you'll see it within the course. So I've got everything's here together, and everything is set up ready for me to generate the videos for the course. And I will start on Monday. I won't be starting tomorrow because that's the beginning of the Tour de France, and I always watch the first day of the Tour de France every year, just one of my little things. But I'm quite pleased that I've been able to generate functions within the actual graphics unit here within the CPU. So I'm going to cut the video short here for the moment, and I will generate another video over the next couple of days, and I'll show you a few of the other things which I've been working on over the last few months, which are different from the CPU design. And as I said, I'm trying to get back into the swing of generating these videos. So what I want to do is, again, just have some fun. I think part of the reason why I stopped doing the videos was that YouTube tends to funnel you down one route, and that the audience just kind of wants one thing, and you can get, if you like, it's kind of like getting typecast. Okay, so you just keep generating the same things over and over again. So I want to break away from that a bit and I want to again have some fun with the YouTube channel, and hopefully that'll get me up and started again, and providing an audience with some useful and interesting videos. So just quickly to have a look and see, you can see all this generating through. So we've got the ROM and the RAM. We've got our control unit here. The control unit has got a counter, and it's got all the sets and all the enables, one side and another side. And we've got a micro-coded ROM. The micro-coded ROM's got this, what I call a compression ROM, which is just a little VLOOKUP table. And we've got the actual microcode here. And you can see all of the outputs here pulsing away. And these outputs are following the microcode here. Okay, so it's all up and it's all working, and it's all very solid. Okay, so it's not throwing up any errors, and it's not running into any oscillation. So I'm quite pleased with the final circuit here. So that's all for this video. Thank you for listening. I'll get you on the next video.